alternating current circuit, it is the same as yesterday. This is continuation of yesterday we had done. This is the third question related to AC circuit. This is also important one. And the power consumed in any circuit. That means in any circuit, how much current is, how much power is. Our aim is to know. Define first. Here is question about define AC power. Alternative current को power भनेको के हो? What would be the power of AC power? AC power, and here is we have an expression for it. What is the expression for it? And also define the power factor. What is power factor? That is our main goal. Look at from this question, what to calculate is depend on here. One is depend on the question here. One is power factor, another one is which expression for it, another one is AC power. Here I have given here, I have written here as answer. You can see power consumed in a circuit. First of all, this is let the alternative current EMF is applied to the LCR circuit B. E equal to E naught sin omega t. We had calculated in the previous videos on that. That was E equal to EMF of the LCR circuit, means one of the circuit which has inductor, which has capacitor, which has resistor. That means the circuit which has inductor, capacitor and a resistor, along with we can see this is what? This is LCR circuit. Suppose I equal to I naught sin omega t minus theta. This is, you know, the expression as it is. This is the expression of EMF in the circuit, in LCR circuit, and this one is the current in circuit. That is I naught I0 equal to sin omega t minus theta. And the power at any instant time t is given by. कुनै समयमा त्यो सर्किटमा कति पावर छ त भनेर निकाल्नु पर्यो भने यो w dw by dt भनेको डेरिभेटिभ अफ वर्क डन विथ द टाइम भनेपछि कति एनर्जी चेन्ज भइरहेछ त समय अनुसार भन्यो भने that would be the multiply, that would be the product of EMF and current I र you know the W equal to VI पनि हुन्छ नि त फर्मुला. हामीले त्यही गरेर W equal to हुन्छ वर्क डन equal to VI भने जस्तै अहिले here you can see the EMF into I. In the place of EMF you can see here EMF E naught sin omega t, because here is from this equation E0 sin omega t. In the place of E I have written I E naught sin omega t into is here into, in the place of I you can see I0 sin omega t minus theta. I0 sin omega t minus theta. Have you understood? Or more may I describe about it? Yes, I think you understood it well. So that look at here, then you know the in the place of E I have written all this value from this equation, and in the place of I have written all this value from this equation. From these two equations, when you substitute this value, then the expression would be like this. And then you can take these two E0 and I0 at this place, and look at here sin omega t as it is. I have copied here, and the same as this here sin omega t minus theta. You know that this is the formula of what? Sin A sin B, sin A cos B minus cos A sin B. So that I opened this one into this formula. So I have written sin omega t cos theta minus cos omega t sin theta from this formula. You know this is the formula of sin A minus B. And then when we multiply here in the third equation, you can see E0 I0 as it is. Sin omega t, when you multiply this with that could be here sin square omega t, sin square omega t. So here is sin square omega t. Cos theta is as it is. Here is minus as it is. Sin omega t is also for this one expression. When we multiply, that would be here sin omega t as it is, and here is cos omega t sin theta is as it is. When you multiply again this E0 sin omega t with this one and this one term, because this is the common for these two terms, and that would be the this one E0 I0 also with this one, and also with the this part. And again when we cross multiply, look at here, this is d theta means change in time. In cross multiply with it, and d theta multiply with this part, and d theta multiplied with this part too. I have forgotten to write here, so here I have to write dt. I have written just right now, so that you can see here d theta, d omega d w means it is the work done. Work done means at any instant how much work done. This is the small work done by any circuit at any instant of a time t. That would be dw divided by dt. Do you understand what it means? It means this is the small work done at any instant of a time. At any instant of a time, suppose small work done dw, then we can write in this way dw equal to this one. And you know that this one is small work done. Your aim is to calculate total work done of a circuit. So the if you have a small work done, from that small, when you try to find the total work done in a circuit, you should do integration. So I have written here, total work done over a complete cycle is calculated by integrating equation. This one is equation from t equal to 0 to t equal to t, capital T. When you start your time, you know that you start to know the power in a circuit from 0 time to t time. How much work done there would be, we can get with the help of what, integration. अब हेर्नु त dw को डेरिभेटिभ इन्टिग्रेसन के हुन्छ? What would be the integration of dw? D. So d cancel each other and cancel with integration w मात्र हुन्छ. So that here is w. And here is 0 to t. I applied here integration because it is given in your this expression, this in your sentence. So 0 to t e0 I0 sin square omega t cos theta dt. You can see as it is this one. Just here is what given. There is just only integration you could see here. Another one is 0 to t is also the integration of the second term. And when you apply the integration, then this part, you know this is the 0 to t sin square omega t dt. When you do the integration, you could find the value 0. So this term would be 0 because the as this term has the value 0, we can write this term 0, so that this term is not here. Just only we have this term. When we find the derivative of this term, त्यसपछि यसको डेरिभेटिभ कति हुन जान्छ? त्यसको sin omega t को डेरिभेटिभ, यसको डेरिभेटिभ चाहिँ when you do the derivative, when we do the integration, I could have told the derivative, but I wrongly said derivative. That was wrong. We all did here integration. Look at here, all the integration of dw equal to w, and the integration of all these comes to be this one. And look at here, now the average power is p equal to w by t. In the place of w, e0 I0 cos theta t by 0. I copied as it is here, and t is also here. T cancel with each other. Then when you find here e0 by omega under root 2 I0 by under root 2, here is 1 2, here is 2 under root 2. You know these two are the under root 2 are the factor of 2, so that I have written this. And e0 by under root 2 would be e RMS, and I0 by under root 2 would be here I RMS, and cos theta is as same as here. So total power in a circuit equal to the I RMS into the E RMS into the cos theta, and this is the required expression for what, AC, in the required expression for the power in the AC circuit. That one is the required power in the circuit, and hence the power factor cos theta. Our aim is to know the power factor of a circuit, so here is given it, and we keep this cos theta in the left hand side, and then cos theta would be here P divided by power of a circuit divided by current, RMS current in a circuit into EMF in a circuit. This way we can calculate the power factor in the LCR circuit, the circuit which has inductor, capacitor and resistance. And the main here is, this is easy, just it is also depend on the somehow here part on the integration, so that you might see it difficult, but it is not as difficult as you think it would be the difficult. But just you first in this while you solving this one, you should know the E equal to E0 sin omega t and I equal to I0 sin omega t minus theta, and you multiply, then do the integration of all this part. Then obviously at last you can get to see this power factor cos theta. That will be the end of this question.